Hello, can you hear me? That's very good. So welcome to this 47th meetup of Paris Women in Machine Learning and Data Science. And we are extremely happy to be here at Criteo again. Perhaps some of you do not know. How many are here for the first time? Right, many of you don't know that our very first meetup back in 2017 was at Criteo. Criteo was our supporter when we were small, insignificant, and some people thought that the idea is a bit crazy. And we're really thankful to Criteo for this faithful support throughout the years. Now we're giant, and we are back with our 47th meetup. And to start the event, I will give the floor to our host, Criteo.
Hello, everyone. Thank you. Thank you very much for coming here. My name is Maria. I'm a research scientist at Criteo. I'm working on fundamental deep learning and fairness in advertising. And I propose to Criteo to host again a Women in Machine Learning and Data Science meetup. And it's a very nice idea and opportunity that we do it again. Thank you everybody for coming. First of all, since most of the people maybe don't know what Criteo is, I will talk about what we do and why we are all here and where is machine learning and AI inside of Criteo. How to do? Okay. So if you ever browsed in the internet online, then you probably have seen ads everywhere on all the web pages. But in particular, you might have noticed sponsored products or any products that you could see when you browse, but not exactly what you look for, but the best recommendations that you could find. This is what Criteo does. You have, you go onto a retailer webpage that you most probably know, for example, Cdiscount. Then you type you want to find a fridge. And then the first that come up, it's sponsored products. Or if you go on your favorite bot of the conversation in some shop, and you ask what is the best product to buy, then Criteo will help you to find the best sponsored product. And it helps to have our internet open, because we also help to publishers, we help the brands to promote them and to get the best idea on what they could look for. And that came up to the very large numbers and large data that we have. So daily we have more than 700 million users browsing on the internet and seeing our ads. We have more than 35 billion of events. And we have more than 100,000 algorithms yearly trained in our engine. Thanks to that, we get the huge amount of data that we use to give the best product recommendations, that we use to improve our engine and give you even better products that you might like. And we also use it to innovate, to improve the research around, and to foster all the recommendations and dynamics and optimization processes internally. So what Criteo is? Criteo consists of 3,500 Criteos, and we have around 19 offices around the globe. A bit less than 1/3 of it consists of R&D, the products and analytics, and some part of Criteo is exactly devoted to AI innovations research, and we have 130 researchers and engineers working in this direction, which is called Criteo Lab. And we have also affiliated academics and PhD students. So in total, part of this community of Criteo Lab works closely with the academics and also part of the academic community. And we publish more than 30 papers per year in top-tier avenues like NeurIPS, ICML, and so on. We give more than 50 oral presentations per year, and we have close partnership with academic universities such as NSAE, INRIA, which help us to help with the AI regularization, with privacy topics, and to help, for example, build the privacy sandbox and so on. We also actively contribute to open sources, especially open source datasets. And you can find our datasets on Hugging Face and also on our webpage. And we actively contribute to medias, and we talk about AI and evangelize about AI across all possible medias. So briefly, what we work on is, I would say, everything, because we have a huge part of us working on deep learning, including LLMs, generative AIs, and connected with advertising topics such as privacy, fairness. We also use a lot causality, and we work also on very statistical problems such as mechanism design, game theory, and so on. And not only we work on a lot of topics, we also have a very encouraging life at Criteo. So we very focused on diversity, equality, and inclusion, and on well-being, and which is highly recognized outside of Criteo. Recently, we started more focusing on sustainability, and we just in February got a very great award that recognized our sustainability efforts. And we have a lot of communities where we organize events, we organize seminars, and we can talk and discuss our problems and inspire. And we also hire. So if you want to learn more, you can check out our Criteo R&D blog. And obviously, you have to subscribe to our Twitter channels. And go check out our open positions in Criteo Lab and outside. Thank you very much.
Thank you very much, Maria, for this insightful presentation. Just to add that we heard quite a few presentations throughout the year from Criteo engineers in this meetup, and actually several people who were working in Criteo at the time were part of the organizing team. So we are old friends with Criteo, and as I said, very happy to be here. And now let me briefly introduce women in machine learning and data science. And who of you know about us? Like, please raise your hands if you know about us. Thank you. Some of you don't. All right. So Women in Machine Learning and Data Science is actually an international organization, and we're a Paris chapter. Chapter just means just a branch. And its mission, our mission, is to support and promote women and gender minorities who study, work, or are interested in data science and machine learning. And I'm not sure whether this slide has been updated, but we know that there are over 100 chapters in different cities, over 30 countries, maybe now even more, and over 67,000 members all over the world. And for many years, we were very proud that we were the third largest chapter in the world after 2 chapters in the US. Ha ha. This year, we are finally the second largest chapter in the world. I don't know who is the first one, but you see, we have more than 5,000 Meetup members, which is obviously enormous amount compared to the modest beginnings. And how you have the team, and actually, we are very happy that everyone is here. So we have Chloé Daudier, who is a co-founder, and Caroline Xavier, who is a second co-founder, who's probably still waiting. And then we have myself. I'm Natalie Chernetska. I've been here, I think, for 5 years now, We have Marie Saxic, who works for CyberAngel. She's been for 4 years, I guess. And then we have Juliette and Jihan, who are also here from this year. So if you're interested how to get involved, how to speak, how to volunteer, how to help, we will be here at the reception and very happy to talk to you. And in general, we're a friendly bunch, and so we don't bite, so you can really come and talk to us. And so here, Caroline is here. You see, here she is in the middle, and here she is our co-founders. So we are just introducing the team, saying that today is a really unique opportunity. Everyone is here, which is very rare. I think one of the most difficult things is actually to find a date that suits everyone. Anyway, so what do we do? So obviously we organize meetups like that, like we are witnessing today. And the principle is very simple. Everyone is welcome to attend, but it's only women who speak. So we invite women from different types of involvement in data science, from students to professors, from industrial research to pure research. We also organize discussions of research papers. Jihan does it quite a lot, either on our own. We do it in presence, we do it online, and also we do it with different partners. We organize different events. Some of you attended our visit to the Museum of Mathematics several months ago, and we do things like that. We organize also events with different meetups, particularly during the COVID. We had many online meetups with different other chapters. And if you're interested in scientific papers authored by or co-authored by women, every Friday on LinkedIn, we promote a paper, and Juliette is very much involved in that. So if you are publishing a paper on the topic of data science, machine learning, you can tag us or contact us, and we will promote this paper to our network. All right, so several announcements what's coming up apart from our meetup. So I said we just had a partnership with Your Data Jobs, which is a job site and also very useful website showing salaries in data science. And they featured our meetup as one of their blog posts. So you can check it out. And our friends with at AI House, with whom we organized paper reading sessions, organizing a meetup in Paris on the 30th of April. So if you are interested, you can go and register. So these are about sort of our forthcoming events. We're probably going to have another event in June, but the dates have not been determined yet. So normally we have an event every couple of months. How you can connect with us? Well, I mean, by any means possible, really. Medium is very interesting because you can check what we have been doing throughout the years. Every single meetup is documented, and the slides of this event is also going to be published. Slides, and sometimes we have recordings, it depends. And we have obviously website, LinkedIn, Twitter, and you can also email us. So anyway, get in touch by any means. So that's for the presentation of Women, Machine Learning and Data Science Paris chapter. And now the agenda for today's evening. We have fascinating agenda. There's really stellar speakers and a very interesting combination of topics. On the one hand, the two first speakers are going to talk about data and energy. Energy is a very hot topic for a variety of reasons right now. Women working on data and energy, I think they're even less numerous than women in data science. So we are really impressed that we're having two speakers to talk about this. And then we have our famous third talk, which is normally on the topic of women, science, society, technology, about the topic of cyber violence, cyberbullying, cybersexism, again, how data can help to fight this endemic problem. All right, so without further ado, I'm introducing our first speaker, who is Djohra Iberraken, data sciences GRDF, and she's going to talk about time series anomaly detection and data imputation in energy field. So Djohra, the floor is yours, please.
Thank you. So hello everyone, I'm very happy to be here. So my name is Djohra Iberraken and I'm a data scientist at GRDF. Okay. here. And tonight I will talk about time series anomaly detection and data imputation in energy field. So before starting the technical parts of the presentation, I would talk a little bit about the company. So GRDF is for Gaz Réseau Distribution France, and it's the main distributor of natural gas in France. And GRDF design, build, and maintain over 200,000 kilometers of distribution network. And problem with this. And we have like 77 of the French population served with 11 millions of customers. And I'm working at the data lab of GRDF, which is an entity of information system direction. And actually, our role is really to answer business use cases of the company by using like data science and AI. And we have like various projects, and also we use like various data types. So we use like text, images, and time series actually. So as the presentation of today about time series, at GRDF we have two main temporal data sources that we use. So actually we have the data transmitted by the gas parameters. To give you a little bit more context, a few years ago, GRDF launched a big project of communicant meters to collect like the data consumption, and this project aims to improve the consumption monitoring, and also to have better energy management. So it's daily data. And second, we have also the data transmitted by sensors throughout the distribution network. And here it's the data of the pressure, the gas pressure, and it's hourly data. So these two data sources forms our database that we use at the data lab for different use cases. So we have like forecasting, we do like prediction for the data consumption of our customers. We also do like predictive maintenance by using the gas pressure. We also, like a few years ago, we start like the studying of the network sizing of the distribution network. But actually, to do like all these tasks I present, we need to have a good data quality. So it's very important in business use cases, in industry. It's very important for us to have like models that are that have a good performances, and it entirely depends on the quality of our data. So that's why I choose today to talk about the anomaly detection and data imputation to achieve this good data quality. Okay. Actually, doing anomaly detection is not as easy as we might think. So when we start doing it, we have like a lot of challenges. The first one is that we don't really know what anomaly is, so the definition of anomaly. In the literature, we can find like anomaly is maybe the deviation from a normal behavior, but what is normal behavior? We need to to choose like a measure or a criterion to tell that, okay, this value is an anomaly because it's over like the criterion, that we choose. And then an anomaly depends a lot on the field. So in finance, an anomaly is not the same as an energy field, and it only depends on the project that we have. So the big challenge here is really to define what an anomaly we are looking for and what anomaly we want to detect. The second thing is that we need to have models that are able to generalize. I talked earlier about the huge amount of data that we have. So we can't, it's just unrealistic like to have one model for each time series. We have 11 million customers and a lot of data actually. So the ability of generalization is very, very important here. Third thing is the lack of labels. In industry, like we don't really have labeled data, and we can't really like do this labelization of our data. So using like supervised learning models is just it's a no. It's impossible for us. So we need to have like unsupervised learning models. And last but not least, actually, we need to have like models that are efficient. We need to find like the trade-off between the performances and sometimes like the memory usage, or maybe the training time, or and so on. Okay, so actually I talked about the definition of anomaly, and here in our use case, we don't really looking for anomalies that are, we don't looking for like outliers or the anomalies that are physically not correct. Suppose that we have like a customer that consume like 1 million megawatt of gas. It's just like possible, like physically not possible. So we have rules that are fixed in our system that detects like the anomaly that are like from outliers and so on. So here in our project, we really look for anomalies that are subtle, that are not very, like very easy to find. Like here, for example, up, we have like an anomaly that is a value that is in an interval of our time series, and it's embedded like in the time series. So we can't do like the outlier detection or something like that. So it's like the scope of our project here. Up. Okay, so okay, so in the beginning of the project, we look at the state-of-the-art model that we have. So we start working on this on the anomaly detection like 2 years ago, and we have like a lot of models. We have the proximity-based methods. We also have the like KNN, for example. We also have predicted-based methods like Facebook Prophet or ARIMA, for example. But for us, like it's very important, no, not important, but we are focusing on the deep learning methods. And at this moment, there is a lot of like GAN and transformers and adversarial training used to detect like the anomaly in time series. And we actually focus on 2 papers, like we have the USAD and the TrendAd, where like we have some techniques that are introduced. I will talk later about the 2-phase learning, which we use like for our project, and to introduce like the methodology or the model. Actually, all the how we can say that, all the tasks and all the things that we did is for answering like one of the challenges. So when we use 2-phase learning that I present to you here, so I will introduce the 2-phase learning and I talk later about the advantage that we have. So here our model is quite simple, actually. It's just 2 encoder and 2 decoder, which are transformers. And here what we did is that in the first phase, we have our signal, like the complete sequence of our time series. And then what we did is that we generate an approximative reconstruction of our time series. And then we calculate like the difference between the generated time series and the original time series. And then we used like this difference, which is like a focus score, as a focus score in the second phases. So these techniques, this 2-phase technique, is presented in the USAID at the first time, but use it also in the TrendAd paper that I talked before. And here, when we do this, like this focus score in the second phase, it's allow us to interesting or to focus only on the part of the time series where deviation are high. So in the second phase, we reconstruct like our signal by only focusing on the period or on the time where the time series where we have like the deviation is very high. So this technique allow us to actually like capturing like the little deviation that we have in the time series, And then the second thing that we did is that we used the meta-learning. Just to briefly introduce the meta-learning, it's just learning a model to learn fast. So we don't need to have a lot of data. We don't need to have a lot of memory capacity, actually, I can say. So using the meta-learning here is as we have a lot of time series. And by doing it, we do like the training phase like very fastly. And the third thing that we did is that we used the adversarial training. And here the adversarial training is very like important because it allows us to have models that are able to have a better generalization ability. So all the things that we did is to respond or to answer to one of the challenges that we have in the beginning. And then here we have our like the encoder decoder, which generate also the time series and doing the adversarial training and so on. To give you more details about the things that we did like in the model, so to calculate like this distance between the original and the generated time series, we use like the dynamic time warping, which is very like accurate in here in time series. And it's better than using the Euclidean distance because we have like the DTW have the ability to align like the time series with temporal shift and distortion. So we have a better like distance calculating of compared to the Euclidean matching. So here, this is for the distance calculated. And also, sorry. And also, as I told before, we need to have, we can't like fix a criterion or measure to define if value is an anomaly or not. So we use like the peak over threshold method, which is a method of automatic thresholding. So it's based on the extreme value theory. You can see the papers in the internet. It's very interesting, and it's allow us to detect like the peaks, which we consider that it's abnormal. Okay. So here's the methodology that we use to detect the anomalies. So here we have some results. Here we find like in blue, we have the original time series. In orange, we have the generated one. And here below, we have the anomaly score, which is the distance between the generated and the original time series. And by using the peak over threshold method, we have the anomaly that are detected here, and it's all unsupervised learning method. We have also here an example with a gas pressure, where we can see like the also the generated and the original time series, and then the calculating of distance by using the DTW, and then the anomalies by using the POT method for automatic thresholding. Okay, so now that we detected our anomalies, let's correct them. So the correction of anomaly is very important because if we have just anomalies, it's not really relevant, actually. So to detect, to do the correction of this anomaly and to do the data imputation, also we have a lot of classic methods. We have statistical one like imputation by median or linear interpolation. We also have like methods like ARIMA and Facebook Prophet I cited before. And for Prophet, actually, it's the method that we use in production now at GRDF. So this project is about the network sizing. So we try to impute the data to know like our the sizing of the network more well, I say. Okay. And to explain you a little bit the pipeline or the methods that we used in production. So actually here we have the daily consumption that we collected from the gas parameters. And we also have in this part the billing data. So the billing data is collected like differently from the daily consumption. So it's like here to consolidate our data that we will predict. In the second part, we do the forecasting. So by using Facebook Prophet, we forecast like the time series. And then we align this prediction with the billing data, actually to consolidate it. And then when it's aligned, we have like the imputation of the data that are identified as abnormal. And then we have our labeled daily energy consumption. And actually the billing data act like it's allow us to be sure that we don't have like values that are far from the reality. So here it's the method that we use like in production to do the data imputation. But actually, we also have, as I said before, we have like daily data consumption, but we also have the gas pressure time series. And in the gas pressure, we don't have like billing data. So when we don't have, what if like we don't have billing data anymore, like in the gas pressure, how we can do to do this imputation by using like methods and to be sure like our imputation is real, because we can't like maybe impute with data that are not relevant at all for our use case. So here, for example, we have like models that underfit, overfit sometimes, and it's not very accurate, and it's just not the imputation that we are looking for. So actually here we have like in 360 and 380, we have like a gap. And this gap here is not very well amputated. So the solution that we found to fill this gap with a good manner, actually, is to use a bidirectional approach. What I said about bidirectional approach is that we take into account like this value and this value here. So the first and the last value that we know. And then here, I like details a little bit, very simple, but very simple model also here. So here we have like x1 to x5, which is like our time series, our signal, and we have x2, x3, x4, which are like a missing value. And what we did is that we have like x1 and x4, x5, sorry, that are known, and that we use, we calculate like the midpoint of our signal here, x3. And then when we have x3, we also calculate like the midpoint until we don't have like missing data anymore. And by doing it, so here it's also decoder, like it's very simple architecture. It's not really, it's just like bidirectional approach. And then here we have like x2, x4, and so on, just until we don't have missing value anymore. And here, like the comparison between like the previous imputation that we have and the new imputation by the bidirectional approach. And here we see that we have like an imputation that is more accurate and more relevant maybe for our use cases. Actually, to give you like some key points of anomaly detection and data imputation in time series, the first thing is that we need to clearly define like the scope and the challenges of our detection. So actually, we need to look at our data, look at our anomalies that we are looking for. We don't need to have like labeled data, but we need to like looking for the anomalies that we are looking for, actually, but it's not very English. Okay. And it's very, very important. I think that when we start like working on this project, it's a big part of the project. Actually, it's like what anomaly we really want to detect and why and how we can do this. And we fix like challenges, and then we have challenges. What methods or techniques we can do to answer these challenges, and so on. I think that it's very important. The second thing, and here like in industry, we need to have like a trade-off between performances and the resources. We have a huge amount of data. We actually not like using methods that cost like a lot in in terms of maybe memory or so on, or something like that, actually. So this trade-off is very important to find. And last, also but not least, actually, it's very, very important to have like a good data quality in industrial systems. Like in academia, we focus on models, we focus on like the architecture of the models that we can use. We have also already like the benchmarking data set that we use, but in industry, by using directly these models is not really relevant. So we need to work on our data to detect this anomaly, to correct the data, to have like a data set that have a very good quality, actually, to have like this, to achieve a good performances in time series, anomaly detection, data imputation, and all the use cases that we can use. So we also hiring at GRDF if you are interested. And thank you very much. And if you have questions, don't hesitate. Thank you.
Thank you very much, Djohra. Fascinating. And I really found fascinating how you face real world challenges with data, which is not perfect quality, and how you look for different methods and solutions to solve this data and detect. And also I find interesting that you decide what is anomaly, like what is anomaly and what is not anomaly. So yeah, and so if you're interested in those topics, you see, you know whom to talk to. But now you have still, we are very good on time, fascinating, perfect timing. So any questions to Djohra? Please do not be shy, because questions will start. All right, so we have, and the microphone is coming, please.
Thank you. Yes, as you said, you didn't have any labeled data for anomaly detection, and I was wondering, how did you evaluate the performance of your model?
Very, very good question, actually. So we don't have labeled data, but what we did is that we take like 100 time series, label it by hand.
I did the same, I know.
And say, okay, let's try to this like little bit of time series. Like we take like 100, and we are like, oh, it's a good performance. So okay.
Okay, I'm feeling better now.
Yeah.
Thank you.
Very nice question. Are you using the detection of the anomalies to try to figure where they're coming from? I mean, are you reusing this data as an input? You try to find out what was the root cause of this. Is it on frequency based? Is it because of, I don't know, environment events or whatever? Or are you reusing this to track down?
So yeah, we use like this. So the anomaly actually comes from sometimes like information system problem, and sometimes from the carte SIM in the gas parameters that are not really works. There is like anomalies that we know that it's just physical things, but we also have like some project with gas pressure where we detect the anomalies, and then we look at our databases to see if there is like some incidents that they have like before, and we work with the métier of GRDF to try to understand where this anomaly come from. So it's very important for us to look before and try to correct them like in the real case. Yeah. Thank you.
Thank you. And we had one more question here.
Thank you, Ian, for the talk. Just a question, when you use Prophet to forecast the consumption, is it on a France level or each PITD, or like each region?
Here, like in production, what we have is that for each, actually, we also, for the data imputation, I don't talk here in the presentation, but we have a lot of time series. We don't need, we can't actually do like one model for each time series. What we did is that we did like clustering of the time series, and then like we have like one model to one cluster of the time series. But actually in Prophet, we use it only for the big consumer of the company. So it's just like one model for each time series. Yeah.
Do we have more questions? Sure. Pass the mic.
Yeah, so thank you for the talk. You talk about the punctual anomalies. Do you succeed to detect system anomalies where the gas pressure is not well balanced or something like that?
Are we looking for can
Anomaly over the system and not just a drop, a punctual?
Yeah, so here we look at all the anomalies that we have actually, but I don't really know if I understand the question, but
Yeah, just if the anomaly is not
punctual.
punctual, but
Okay,
not really long term.
it's not the thing
I
that
think we will
okay.
discuss that.
I think that
after.
understand. I think that understand. So here what we use is that our model, she did actually, is that we learn the distribution of the time series. So it's punctual or not, we just like when we're looking for time series and try to generate it, all the little deviation not taken on, we don't take it like in consideration. So that's why also for the punctual anomalies, it's like detected also. So I don't know if it's responds to your question, but
Yes, thank you.
okay, thank you.
So I think we are if you're too shy to answer questions, maybe you can brace up for the next speaker, but let's give a big round of applause to Djohra. Thank you very much for this enlightening talk. And she will be, obviously, if you want to talk to her after the event, you can talk to her also in person about anomaly detection and data and working for this company and working on energy data. All right, and we will move to the next speaker. And the next speaker also works on energy data, and we are very happy to have Margaux Brégère with us, who works both at university, at Sorbonne University, as an associate professor and also a research engineer in industry. This is fascinating. So she sort of has two hats, and she's also going to speak about learning for demand side management, also about energy data. Margaux.
Thank you.
Okay, thank you very much for the invitation and the introduction. So yeah, I'm gonna talk about sequential and reinforcement learning for demand-side management. So the main part of this talk will be about what I did during my PhD. And I will conclude it with some more current research I'm doing with two of my PhD students, which are, by the way, also women. First of all, I'm gonna introduce the industrial problem. So basically, what is demand-side management? Okay, so here it's a little illustration of the electricity system. So you can see at the right the power plants. So basically hydro, oil, nuclear. And all these big plants are connected to the grid. And so the electrons circulate in order to bring electricity in your home and, of course, on big companies. The main issue with electricity, it's that it's really hard to store it and or it's inefficient or very expensive. So this is why we have to maintain the balance between production and consumption in order, for example, to avoid blackouts. Currently, what we do is that we forecast the demand and we adapt the production accordingly. So in my research and development department at EDF, there is a team of data scientists and machine learning engineer and researcher, which I belong to. We try and which try to predict as precisely as possible the demand. And there is another team with some people more specialized in optimization. And these people optimize the planning of the power plants in order to produce the correct amount of electricity. As you may know, today we are facing climate change, and we try to integrate more and more renewable energy into the production. The problem with renewables is that they depends on the weather, and it's really hard to plan the production. In the same times, the installation of smart meters allow the access to data and also the communication with the consumer. So today we are exploring some new solution. We actually try to do the opposite and try to influence or to control the demand according to the production. So to do so, we will, for example, send some incentive signals, like some change in the electricity prices, or we are thinking about trying to control some flexible electrical devices, like, for example, the charge of electric vehicles, or try to pilot water heaters, for example. Okay. So now I'm gonna explain why we are in a reinforcement learning setting. So here, actually, the environment is unknown. We don't know how consumers are going to react to change in the electricity price. But actually, we can discover this behavior by sending them some different prices. So we have to explore this environment, so to learn the consumer behavior. But of course, in the same time, we want to send the good prices in order to make the power consumption reach the renewable production. So we want to exploit our knowledge to optimize the prices. So there is this trade-off between exploration and exploitation, and this is why we are in a reinforcement learning setting. Here I plotted the power consumption of 1,000 households in London, and it's in this experiment they change the prices of electricity. So in dark green, they put high, very high prices of the electricity, and you can see that there is a drop in the consumption, while here and here the prices was low, so the consumption increases. And you can also see that this increase depends on when we send the signals, because if we send them during the night, few people will wake up in order to turn on some devices. Okay. So now I'm just gonna introduce the mathematical tools we used to model this demand-side management problem. A lot of people in Criteo are familiar with bandits, but I'm gonna do a quick presentation about them. Okay. So in a multi-arm bandit problem, a gambler facing a row of K slot machines, and the slot machines are also called one-arm bandits. So this is why we talk about multi-arm bandits. Anyway, okay, and so so the gambler is facing a row of slot machine, and she has to decide which machine to play in order to maximize her reward. So here again, there is a trade-off between exploration and exploitation, because we want to test many harms, so to explore, but of course to maximize the reward, we want to exploit and to play the best arm. So mathematically, we can model this problem this way. So to each slot machine, we associate an unknown probability distribution nu k. And at each time t, we are going to pick an arm yt. So this is a random variable, okay? And we will receive a random reward, yt. And the main assumption of stochastic linear bandit is that conditionally to the arm we choose, for example, if yt is equal to k, then the reward yt will be sampled from the distribution nu k. Okay. Now we want to maximize the cumulative reward, and this is actually completely equivalent to minimizing a quantity called the regret. And actually, the regret is a difference in expectation between the cumulative reward of the best strategy and that of ours. What is the best strategy, actually? The best strategy is what we would do if we know all the problem in advance. So if we know all the distribution nu k, actually, we are going to play only one slot machine, the one with the maximum expected reward. Okay. Okay, so this is a definition of the regrets, and a good bandit algorithm has a sublinear regret. So namely, the ratio between RT and T tends to 0. Why we want that? Because if we do something, for example, completely random, then the regret will be linear. Okay. I'm sorry to disappoint you, but yeah, this model doesn't fit with real casino. And but anyway. Okay, so here it's a very famous algorithm called the upper confidence band algorithm. The idea is to start by picking each arm one time, and then at each time t, we are going to estimate the expected reward of each slot machine using the empirical mean, for example. And then we are going to build some confidence intervals around this estimation. And the idea is that with high probability, the true expected reward mu k will be inside these intervals. And then we are going to be optimistic, and we act as if the best possible probable as if the best possible probable reward was a true reward, and we are actually going to choose the next arm accordingly. So namely, we pick the arm with the upper confidence band. Okay, and when we do that with some assumptions, when we use this confidence band, we actually reach a sublinear regret, so which is very good. And I know that this formula are a bit hard for, but my take-home message here is that the confidence band here for the slot machine K is decreasing when we are playing K. So if we are playing a lot the slot machine K, then we become more and more confident about our estimation. So the interval is very tiny. And if we stop playing the slot machine K, then the confidence band is going to slowly increase. And so at some point, we will have to explore again this slot machine K, probably to see that it's not a good one, but anyway. So this is how the trade-off between exploration and exploitation is achieved by this UCB algorithm. Okay, so now we're going to go back to demand-side management, and I'm gonna show you how we model the demand-side management problem using the Bandit framework. Okay. So here we suppose that at each time t, we observe some context variable xt. So for example, the weather, the day of the week, the hour of the day, etc. And also a target. So basically this target is the production, so the renewable production we want to reach. And then we will choose the tariff PT. So actually in the Bandit setting, it was a slot machine. Here it's the tariffs. And we observe then the resulting electricity demand, which depend on the context and the prices plus some noise. And then we suffer a loss. Okay, so we had to make a few assumptions in order to get some theoretical results. So imagine that we have an homogeneous population and that K tariffs are available. So for example, low, normal, and high. And that PT is actually a vector in a subset of the simplex in dimension K. So for example, the idea here is that you can split your population in two and send, for example, to 20% of the population low tariff and to the over 80% high tariff. Normal tariff, sorry. Then we also assume that the expectation of the consumption is actually a function of the context and the prices, and that we can express this function as a scalar product between a non-mapping function phi and an unknown vector parameter theta to estimate. Actually, this assumption is quite fair because in a lot of models we are using in my department in order to predict the power consumption, we can express it like that. So this is a fair assumption. And then we also make some assumption about the noise term. Okay, so this noise term is the scalar product between the vector PT and a random vector of variance covariance matrices sigma. Here is just this assumption allows us to model the fact that when we send, for example, high or low tariff, the consumption is the variance of the consumption is higher than when we stay on a standard tariff. And then the loss is simply the quadratic difference between the consumption and our targets. Okay. These assumptions allow us to calculate the expectation of the loss. And here you can see in the formula that in order to optimize the prices we pick, we have to estimate theta and sigma. And actually, we have to estimate sigma offline. And then at each time t, we are going to estimate the parameter vector theta using a rich regression. Actually, doing that is exactly the same thing as when we estimate the mu k expectation in the first algorithm I presented to you. Then, using the estimation of sigma and theta, we are able to estimate the loss for each price and to get some confidence bands on this estimation. Then we just select the prices optimistically, exactly as on the upper confidence band algorithm. And we are very happy with this algorithm because we prove a regret band on it and a sublinear regret band. So we are not doing something completely stupid. And here you have the element of the proof if you are interested, and the reference to the paper. Okay. So now here is the application. So in dash line, you have the targets. In the plan line, you have the consumption. But what is important, I think, it's here in the bottom of the curve. So you have the tariff we send, the algorithm send. So in dark, it's high, normal, and low. And you can see that at the beginning of the algorithm, actually the algorithm is picking randomly the tariffs and sending them to the entire population. But at the end, he managed to split the population, to give or to a part of the population here, for example, a low tariff, and here a normal, and like that, it reaches the target. So yeah, you can see it's quite different at the beginning and at the end. We extend all this work to integrate some operational constraints, like, for example, not sending a high tariff during a month and things like that. And also to personalize the sending of the signals. So this is a extension of our work. And yeah, I will just finish with in two words, with over approach and prospect. So with one of my PhD students, Bianca, we are working on how to control flexible electrical devices. And now we are not trying to estimate some theta vectors and all that stuff, but we try to estimate online a Markov decision process. So we can talk about that during the cocktail. And finally, with one of my other PhD students, which is actually in the room, and will be probably happy to talk about this work. We are not exactly doing demand-side management, but we are using bandits in order to optimize the architecture of neural networks. And these neural networks are used to predict the demand. So, okay, so this is all. And if you have any question.
Thank you very much, Margaux, for this insightful presentation about demand-side management and different techniques you can use. And we are opening the floor to the questions. Right, so I'll give you the microphone.
Hello. Okay, so my question is very simple. It's, I mean, I am by no means an expert in data science, so I'm just saying it up front, but I am quite knowledgeable about the finance side. And I know that pricing, especially for commodities, is quite subject to volatility. Like the pricing goes up and down depending on how the traders see today's events. And I was wondering if the model was stable enough to withstand the volatility that is generated by the trading behaviors.
Okay, so so electrical market is quite complicated, but here we are actually looking at the problem on the point of the consumer. So there is a market on one side. So yeah, and but you don't pay the price, the electricity prices of the market. Okay, so if we want to okay, sorry, yeah, if you want to include the market into this problem, actually we have to do it here on the loss function. Because yeah, you know, when EDF is signing a contract with some consumer, tarification is fixed. So the idea here is to propose some prices that are dynamically changing, but for example, you have free tariff and many constraints and yeah, the prices will change dynamically. But yes, we don't look at the market in this, the electricity market in this application. We are just, yeah. But here, I think you can like ponderate the loss depending on the price of the market. Yeah.
I was wondering, is this type of learning is used to actually decide what the EDF tempo prices will be? Because when you are a customer, I am,
yeah.
on the tempo mode. On the tempo mode, there is 6 tariffs, and it depends on there is a subset of days per color. You have white, blue, and red.
Yeah, I know.
And the red is linked to the temperature and to the power consumption of the reference. So are you using this type of model to manage the tempo tariffing?
No, sadly not yet. No, it's done by the operational entity. It depends if it's EJP or tempo. One is decided by RTE, the other by EDF. But anyway, yeah, it's really depends on the weather and how. For example, if one of if a power plant, a nuclear power plant is shut down or something like that, then they will decided that tempo, red tempo or something like that. But no, we don't use yeah, this kind of. But actually, yeah, it's very tempo is quite difficult because they wanted to stop this tarification, but with the energy crisis, they said, "Oh no, actually, it's quite interesting to have it." But in the model, it's very difficult actually to try to understand how people react to this special tarification. And generally, we just remove tempo days from the training data to try to for learning models to forecast the demand. So not yet.
So perhaps it would be an interesting research project for a student to investigate how people react to this and collect more data and figure out how you fine tune the algorithm based on these new use cases.
Yeah, exactly. No.
Well, that's your reaction, but maybe people react differently. So do we have more questions? So you're all paralyzed by electricity prices. So you can ask about mathematics, you know.
Hi, thank you very much for the presentation. It was a great introduction for multi-arm bandit concept. I would like to know, how do you convince your stakeholders to run your exploration phase? Because suggesting discounted price to random clients could be something risky for some people. How do you do it?
Yeah, I know. Yeah, like this part is quite quite difficult to for clients. So this was very it was like basic research here, and actually to get this simulation, we use simulated data because, of course, nobody wants to let me experiment things. No. But yeah, so in the extension here, we are actually able to put some constraints on the vector P here we choose, and we can actually okay, so P is actually a big vector, and you decide the prices of all the day, and like that you can put some constraints here on the set of P and say, for example, you cannot like change the prices every half hour or things like that. I don't know if it's convincing you or not, but if you want.
All right. So I think we should stop and give Margaux a big round of applause. And if you want to talk to her, you can obviously do it after we finish, and she'll be happy to talk about mathematics. And also, if you want to volunteer about becoming to guinea pig of those experiments, I'm sure there's a place for you. Just kidding. Thanks a lot, Margaux. And now we are introducing our third speaker, Chloé Daudier, who is going to talk about how AI can fight cybersexism and cyber violence. It's a very important topic. Obviously, you are all well aware that this is a growing concern and what AI can do. And I just would say we were following each other with Chloé, our meetup, and her for a while, and we're really happy that she's here with us today.
That's really impressive to be there, and thank you very much for the invite. That's a heavy subject, and that's why I try to do my best to make it less heavy, even if I will be serious at some moments. I hope you will enjoy it despite of all. So why and how AI should fight cybersexism? I choose all of those words and I will explain them to you. So this is with Equilys. Equilys is my own company. I'm my own boss and I'm very proud of it. And this is my name. So if you are looking to reach out, you can contact me on LinkedIn. Who am I? So this is one of the things I made to make it less heavy. I'm a feminist, I'm a scientist, and I'm creative. I'm a creative person, and I think that creativity and science are related. But I really don't like salary. And I really don't care about the debate on chocolatine or pain au chocolat. But maybe you are here not to know more about me, but to know more about what I do. And this is what follows. So I do many things, and one of the subjects I'm working on for now is a board game to show diversity in science and to make people know more scientists, women scientists. It was a project I had in my mind for a long time, and I decided to make it real. So this is why I'm launching a crowdfunding in June. Do not hesitate to contact and follow what I will talk about on the social medias. I'm not really good at communication, but I have no choice. I'm also a science communicator, and even if I'm not good on social media, I try to speak as much as I can, like today. I do videos too, and that's a big achievement in my life. I do podcasts, and I will launch my own podcast during this summer. Also to show diversity in science and amazing women. One of the other subjects I work on is the Open Science Project and the Festival Double Science that will take place in 8 and 9 of June this year at Grand Control in Paris. Is a festival to make science accessible for everyone. So it's also related to diversity in science. But doing all of this and not earning my own money was a problem. So I decided to build my own company, and this is why I became an entrepreneur. But it was something I started for 3 reasons. I wanted to work in a safe space, safe space or safe workspace. Because when I did my internship, my last internship at the end of my studies, I had to deal with 5 months of sexual harassment. So I was not really prepared to work in a company in those conditions. And I wanted to work on projects I like. So this is why I am an entrepreneur now. I'm not doing enough AI, in my opinion, but I'm trying to deal with it and organize my skills to do more AI. And this is what I'm talking to, I will present to you today is one of the 2 projects of AI I'm working on. The first one was the Big Data AI program that I co-developed in Data for Good. And I know that if you already came here, some of them might have heard about Data for Good and Big Data AI. And the speaker is actually here. So Sandrine, thank you for presenting Big Data AI some months ago. But the project I'm presenting to you today doesn't have a name yet. And this is the project that does not have a name yet. Once upon a time, I met Rapunzel Princess. Rapunzel is a real person, but I choose to not say her name. Maybe you will guess, maybe you will see on social media that I already talked about her, so you will find who she is. But I thought that was more funny to have her here. And Rapunzel is a feminist. She is really willing to change the world. And one day, so she posts regularly on social media. One day, one video was posted. It was an interview of her, and it made a really bad buzz. So the circumstances of this video are her story, but the fact is that online hate raids started on her own channel. And it had a big psychological impact. Her address and coordinates were given on internet. And she was really afraid she was threatened. So she was afraid of being assaulted, or I don't know, but she left Paris. And she decided to go to the police and file a complaint. But it was really a lot for one person, so she asked for help. And this is when I met her. I tried to be a valiant knight, yes. I don't know if the word exists, but in French, I'm trying to make more feminine words. So I was wondering what I could do with my skills in AI to help her process data and not having to look at them and be confronted to the problem of cybersexism and cyberbullying. But I had a lot of preconceived ideas, and these are my hypotheses. The first one was that cyber harassment is related to massive volume of data. We'll see together if that was true or not. The second one was that every time a hater posts a video about her, it gets worse. Because other men published videos about her, talking about her, and there were pikes in the cyberbullying she lived. So I thought that every time someone posted a video about her, it gets worse, yes. So hypothesis 3 was that it's easy to classify by sentiment with language models. It was not. Hypothesis 4, harassers hide behind fake profiles. Of course, there are laws, and it's forbidden to harass someone, so they must have hide. Spoiler alert, no. Hypothesis 5, she was harassed a bit because she is a big mass feminist, and maybe it has something to do with it. And I was wrong. If you have other hypotheses, do not hesitate to write them down, and it could be a good base to talk about it later. So first hypothesis, massive volume of data. That was true, massive for me at least, and for her. So I used the YouTube API to collect the comments based on some channel URLs, so her channel URLs, and I added some other videos, so the videos of the men who were talking about her. And from the comments, I did other tables of channels, videos, and authors. And we get 40,000 comments on YouTube, just on YouTube. This is a number I found in other cases of cyberbullying of other feminists. So if you are not really famous, but just a presence on social media, you can have this kind of order of magnitude of comments of cyber harassment. The second hypothesis is that every video has an impact. This graph just shows the chronology of all the comments she received. So here, yeah, the 7th of July 2022, that was the day the video of the video that provoked all of this was posted. And there were some days then she had a really big spike of cyber harassment. But all of those little marks here, the blue ones, there are the dates where the video, when the video of other masculinists were posted online. And actually, we noticed that even if it's hard to determine if there is a causality between the the dates of the video posted and the cyber harassment, we noticed that most of the time people just surf on the waves of cyberbullying and they do not provoke it. But some of the videos did probably provoke it. And that's an interesting field of research. I hope I will have time to work on. So yes and no. Yeah. The third hypothesis, it was easy to do sentiment analysis. I was alone, and it was the first time I had to do this. So I noticed that in cyberbullying and with the comments I had, it's sometimes hard to define who the person is talking to and talking about. For example, you can have a feminist, so I will simplify with hater equal masculinist and supporter equal feminist, but you have the idea. So you can have a feminist defending another feminist and being a bit aggressive in her comments, but it won't say that she is aggressive to Rapunzel. So that was the first challenge I had. The second was that cyberbullying is not the same as reviewing an object on Amazon. So when I started to find and to search for Hugging Face models, pre-trained Hugging Face models, I went on NLP Turn, tried it, and I had really bad results. So I realized that Amazon reviews are not a really good data set for training a model to detect cyberbullying. So I wanted to go further. And I noticed also that there is a specific vocabulary for masculinists. We will talk more about it later. But I wanted to try large language models like GPT. And this is how I made my friend lose 300 euros, because I thought I found something, a really good prompt that worked. It actually didn't. So it was for nothing. I thought it would work because on ChatGPT it was really efficient and I had no problem detecting problems in the comments. But when I started to use the API and DaVinci, for some people who know, it was not really good. So I may be a really bad prompt engineer and I really want to improve, but I was traumatized. After that, I felt really bad, and as I don't have any money myself, I didn't push further this model. So as I told you, community has its own codes, and this is why large language models are necessary. So this is the why I wanted to explain at the beginning in my title. Why AI? Solutions. So when I was traumatized, I tried to do other things. And in those other things, there was the word clouds, easy to show, very interesting, but not really practical to file a complaint, because that was her goal at the beginning. I also tried topic modeling, and actually that was really interesting because in the topics we found, there are of course the attacks on she's a female and she's, yeah, all the masculinist things we can hear most of the time. So discriminations, all the discriminations, they pop up here. And one of them was about being crazy. That's not really surprising, but that was really interesting to have those kind of topics just being popped up. But I wanted to help, so making games was not really the idea, and I decided to focus on authors. If I couldn't analyze each comment at the same time, I wanted to identify persons she could point at the police, because most of the time when you file a complaint to someone. So you have to have a name, or at least a profile name. And this is what I did. So small Streamlit interface and small database you can access. And for each of the main authors of the comments for her channel, it's just displays 5 of the comments. And really quickly, you can guess if the comments are support or hate, or neutral. Sometimes there are really not a lot of neutral comments. But yeah, it was interesting. So we went to the police at this time, and we had some info to give. We'll go back to this just after that. I want to try again with GPT, and I want to try again with few-shot learning, because I think that's more of hate and love sentiment classification. It could be interesting to classify by legal categories. So is it a threat? Is it an insult? Is it based on her gender? Is it based on her physical appearance, of her religion? And yeah, the idea and the goal for me is to be able to do that. Harassers hide. So what I did with it allowed me to have this. The purple ones are the support persons, and the gray ones are the haters. And those are the 100 more present persons on her channel. So at the beginning, I was looking for fake profiles. Do they have a picture profile description? A picture profile, a description? Do they have a name or a random name? And is the creation date recent? But actually, when I tried to do that, I was blocked by the YouTube API because it was too many requests. And I realized with this graph that I didn't have to do that, because most of the time, hater does not hide. And so here, we have one of the most frequent haters she has on her channel. Okay, the last one. She was harassed because she's a feminist. That's really, really false. So I digged into the statistics about cyberbullying, cyber harassment. I discovered that actually 87% of young people already have been victims of cyber violence. Cyber violence is cyber harassment, but also other kinds of cyber violence. And for example, what we call porno divulgation or revenge porn, but this term is not good. And instead of revenge porn, so that's my awareness moment, instead of revenge porn, you can use image-based sexual abuse, because the fault is not the person who have been harassed. It's the person who divulgated those kind of image. So yeah, 87% is a big stat, but in the victims, 84% of the victims are women and girls. Most of them also are queer persons, so they are gender minorities, or or lesbians and gays. And the impact that everything all of this has an impact on those victims. And 32% of the victims have deactivated their social accounts. So this is a French study, but in the United States, it gives up there more or less the same results. And I really recommend the Feminists Against Cyber Harassment and HIPSO studies. It was from 2023, I think, and I forgot the date, sorry. To conclude, there are different kinds of cyberbullying, cyberbullying and cyber harasser. So some people will just publish hardcore comments, and those are the threats, the insults, the sexual harassment, and this is really legally reprehensible in France. And it's not that hard to identify. You can just make a Control F thing, and most of the time you can find already interesting matter. But it's not that easy. That's why I think that LLM has a really role to play, a really big role to play. There is also one person repeating abusive comments. So this is what we could identify with the most frequent authors of her channel. One person repeating abusive comments can be really easily identified. What is hard to identify is a herd mentality, or what's called in France the effet de meute. And harassment can also be one message repeated by different persons having the same goal, to destroy one other person, the victim. So this is just some extracts of what she could have. This is one of my own. I had this when I was in university. And this is the kind of cyber violence I was talking about earlier. So for those, for people who does not speak French, he told me, you'd better not be on my way at the university. You don't disrespect me without consequence. And she had many other nice comments, like insults, like, please kill yourself, to be short, drink bleach. And this is an example of what I told you at the beginning. Some people have symbols that are specific to a community. So this medal is related to one masculinist on the social media who posts videos and has a symbol. So that's interesting, and that's what leads me to this. What is interesting for me is to identify the person who are responsible for the cyber harassment. And with the word analysis, with those kinds of identification, you can go back to the influencer who was there at the beginning of the harassment. So there is the wording, there is also the connections between persons. So if you are following someone and you are also following someone else, they are related through you. And some people already made some data visualizations and studies, like Kevin Lemonnier and Flev Graf and Stéphane Capot. Yeah, I don't know if there are good people in real life, but those graphs are interesting. That's one of the subjects I want to dig in. I made video analysis here, just to say that the influencers, they are not really, at the beginning I thought that they were saying, you have to harass this person, but they are not stupid, they don't say that. So video analysis is not really an interesting thing to dig in, except if you want to go further and identify deepfake porn or image-based sexual harassment. So yeah, that can be something. But this is specific because I met someone who told me that she didn't want to go to the police, but she was victim of deepfake porn. So I think it's really interesting and important for us to talk about it because it's new. It works well every time I mean, it's improving, and it's becoming more and more realistic. So it's becoming a real problem. But for now, it's not my field of competence because we still need to do legal regulation. And I think that to find people and to, it's harder to identify those persons because they hide more than the cyber harasser. So it's a cybersecurity task, and that's not my skills. I think we can also do something about preventing. So if you are leaving cyber harassment, but just at the beginning, and you see the time series, so that's interesting. Thank you for your presentations. It can be interesting to detect one of a big rise of cyber comments and harassment, just to protect and to raise an alert. Be surrounded by people who loves you and take care of you. Yeah. If you want to go further, just send you some interesting sources. So there are films, movies, associations, and books and studies. And do not hesitate to reach out either on my LinkedIn profile or on Equilys AI. I don't know what hyphen. No, it's not hyphen. What's the dash? Thank you. Equilys-ai.com. I'm doing my website again, so for now it's just give me your mail address and I will contact you later. Thank you very much.
Thank you very much, Chloé, for talking about such a difficult topic and such an important topic, and trying to show us the different aspects, how you actually can fight it, what you can do with data, how far you can go, and also what are the limits of the data. So really appreciate, and also stunning visuals. I mean, people who work data for good always present amazing visuals. That we already noticed. Do we have any questions from the audience? So we'll start with you.
I've noticed the last slide around network detection, like you were showing the graphs. And I was wondering if you explored the graph databases paradigm for data, because I worked with graph native databases, and they do actually have graph data science libraries that could be quite useful for network detections and connections. I know it was used for the Pandora papers, the Panama papers, and I was wondering if you explored that, and if not, then it might be a tip.
Yeah, thank you very much. I didn't have time yet, so no, not yet. Thank you very much for the idea and the reference. Yeah, I will ask you to write it down, please. Thanks.
So we have another question.
I wanted to ask if you had worked with lawyers on the topic.
Yeah, not really work with lawyers, but I asked to lawyers what they're thinking about it, and would it be useful for them? Because that's also what an entrepreneur should do. It's detect the markets, but they are not ready to pay for it. So that was one of my main questions when I started to ask, because I didn't want the victims. If I want to earn money on this, I have to make someone pay, but I cannot make the harasser pay. So I didn't want to make the victim pay, and I turned to the lawyers. And actually, as they don't do that now, they don't see how it can improve their work, because it's not a work they do now. Some of them do this, but most of the time they do this with the victim. So the victim has to select for the lawyer.
Les huissiers.
Yeah, I was thinking about the huissier too, but I didn't have the opportunity to talk with one of them. Yeah, they should. Yeah, that's a real problem. And I'm in different groups of feminists, so they are really active to yeah, I don't know, let's say, raise the awareness, but also raise an alert to Pharos and to the social media. And most of the time, I tried it on TikTok, for example, and there was no problem for the platform.
We have more questions. Oh, quite a few, so microphone can travel. So here, one's there
Hello.
and one's there. Okay.
I just have a small question. I just want to know like the topics that you are going to talk about in the podcast that you're going to launch this summer.
Yeah. Whoa. That's yeah.
Yes.
It's just talking, just chatting between scientist women. And some of them are not in the science fields anymore. Some of them are reconverting, in the scientific domains now. So the idea of the podcast was just to discuss together and show that there are a lot of scientific women or creative women or really various women, scientist women. And I want to start, as you do here with WiMLDS, I want to start a community of scientific women.
Fascinating project, fascinating project. So plenty of people here probably will be very, very happy
Alright.
to listen and maybe participate.
Thank you.
Lastly, I just
Another
want to
question
know
and another question.
in which platform you're going to launch your podcast. Like, if you
I don't know yet. I was just thinking about Spotify, or
all right.
there are some other words, like some other platforms. If you have ideas, do not hesitate to talk to me just after.
Okay. Fine.
Yeah.
Thank you.
We're just for now recording. First step.
Hi. I was wondering about when you get the data from YouTube. So I don't know about how the API works, but will it be possible once we have this data to do the analysis and block the user and do not write down the comment at the first place? So it won't even reach your friend.
Yeah, that's moderation, and it's possible. That's one of my main competitor does. Bodyguards, I don't know if you know it, but Bodyguard is not dealing with individual problems now. They're just focused on B2B. But that's what they do, so it's possible. You can access comments, you can moderate them.
So is it only YouTube, or it can be done like with TikTok or Instagram?
Yeah, it can be done with other platforms. I know that Twitter is a bit tricky about the API. But I know that Instagram allows it and TikTok too. So for now, I'm focusing on YouTube, but that's probably for sure something I will develop.
All right, and we had one question here. All right, so this. And that will be the last question because the time is running, but obviously you can talk to Chloé afterwards, but one question we're taking.
So what you were saying before with the platforms that don't do anything, what about government? Because I saw on your last slide you had also some label, something about the government. When there's a law and they have to reinforce it, how can they not do anything, or is there anything that is going on already?
Yeah, I think not. Transformer models are quite new, so they may just didn't have time to implement those kind of solutions. That's what's just I'm thinking of. But yeah, probably people don't see the problem because they are not concerned. They are not. Yeah, if we had more women in teams, maybe it would be priority. I don't know.
If it would be men, then it would be a huge topic, I guess.
Yeah, probably, maybe. I don't know, but I just suppose that they didn't have time to develop it yet. And it's hard today because to access the persons from the profile, they have to wait for the it's not a tribunal, but it's an instance, and only this instance can access the data, can request the data to YouTube, to Facebook, and so they make a request in the name of government or police, and they may have an answer to identify the person. So there are other possibilities to find someone, and this is not my field of expertise. But when people leave traces on social media, we can sometimes just find their LinkedIn profile, and yeah, I don't know if it's acceptable as a proof for a jury. I'm not a lawyer, but I'm digging in just to know more about the métier.
Thank you very much, Chloé. Thank you very much. And this requires obviously giant effort from lawyers and from the platforms. But I think what you're doing is very essential because you're raising the awareness, you're raising the alerts, and also you're debunking some of the myths that some of us might have. So thanks a lot for your work, and obviously you're welcome to talk to Chloé afterwards and follow her on LinkedIn. She shares all kind of useful information. So thanks a lot. And so with that, we have finished our official part of the meetup, and we are going to our unofficial part, kindly supported by Criteo, which is networking cocktails. You are welcome to talk to everyone, to each other, the speakers, to the team. And maybe the people from Criteo will guide you where we have to go. And the speakers, and could you stay for a while? We'll take picture of everyone, but official part is over. Thank you for being here.